Welcome. In this video I'm going to show you how you can obtain the one sample Rank Biserial Correlation Coefficient using Python and either scipy and or pandas libraries. I'm using Jupyter Notebook with Python version 3.818, and this is specifically for the one sample case, which is very similar to the paired samples case. There is also a rank biserial for independent samples. That one has a slightly different formula. In these cases, the ones that I'm showing you, it will be actually the same as the sum of the ranks of the scores that were below the hypothesized median and those that were above as a proportion of the total sum of all the ranks. To show you an example, I'll need some example data. For that I'll import pandas, and then I can load the GSS 2012, so General Social Survey from 2012, adjusted for these example purposes. I don't need actually all that data. I only need one ordinal field, so I'm going to be using account sci, which is short for accounting scientific, and I'm going to put that as ord field. It has the responses on how scientific accounting is according to those respondents. To give you a quick impression of the data, the value counts. So for example, 199 people thought it was pretty scientific. I'll put those options actually as a small separate dictionary. And I have a separate video where I explain how you can do this very simply with my own library. But if you want to use other people's libraries like scipy and pandas, then I first actually remove all the missing values. I set the hypothesized median, so let's say 2.5. And I also therefore need all the data to become numeric, so I'll use the replace option and then quickly check if now everything is indeed a number, and indeed now these are numbers. Now if I want to use scipy, scipy actually has a Wilcoxon test. So if I use that test, it actually returns the sum of the ranks of either the ones that were above or below. I think it's doing the minimum of those. But once I have one of them, it's fairly simple to get the other one, because the full sum of ranks is simply the number of ranks that you actually have multiplied by that same number but then plus 1 and then divide by 2. However, this does exclude, it's the number of ranks, it excludes the scores that are equal to the median. Now in this case there weren't any, but just in general you need to watch out for that. So this can actually get you the complete number of ranks that are used in the calculation, and then we can fill out this formula to get the complete sum of all ranks. So then the other category must simply be the difference between those two. So then we get indeed, as we can see now, so the ones that one of the sum of ranks is this one and the other one is this one. One is for the ones above the hypothesized median, the others are for below. Now we can fill out the formula for the rank biserial coefficient, which sometimes looks like this. Looks perhaps a bit scary, but we actually have everything, and this t is just the minimum of the two sum of ranks we have, and we can use Python's min function for that, and then just fill out the formula and we get our result. We can also use a simpler formula, the one that I actually mentioned in the beginning, and as you can see that gives the exact same result. If you want to use pandas, that's also possible. Then we'll simply create a ranked data frame where we actually put, we first calculate the differences between our accounting scientific scores and the difference with the hypothesized median, the absolute differences. Next. No, sorry, these are actually the differences. We also need the absolute differences. So let's take the absolute differences. So those are in there as well now. And then we can use the rank function from pandas to actually rank all those absolute differences. The sum of the ranks for only differences that were positive, we can use the query and then sum. And this gives me all the sum of the ranks of scores that were above the hypothesized median, and this is the one for below. We can now simply use the simple formula and actually obtain the result. And as we saw earlier, that's again the same result. In a separate video, I'll show you how you can do it without any of the libraries. Alright, I hope this was helpful and thank you for watching.